Hello, and welcome to this, I guess, video conference. I'm very glad that you guys are all attending the brew. I have done so in the past, and it has been a very positive experience in my life. So I'm really glad that you guys are attending, taking part, make some new connections. So I was asked to talk about how to be a productive researcher, and just a caveat right away that your mileage may vary. This is all based on my personal experience, and um, let's get to it. So overall, how does successful researcher, it requires really defining what you mean by success. And I would go as far as saying that there are very many different ways in which scientists are successful. There's this famous cartoon from the NIH where you have big talkers who sort of talk their way to success. You have slave drivers who just get lots of people to work for them for a large amount of hours, and that produces success. There's some demigods that are well connected and know everything about the field. They just have sort of gravity in the field who are successful. Control freaks who just who are good and precise and get things done. You have people who are excited about science. You have people who are sort of laid back and let good people do what they do best. You have people who are extremely pushy and thereby achieve success. And there are people who are just really good at their own niche, the small-town grocers. And there are people who are they're up and coming. But the joining feature is that really success is largely subjective. And I mean, you can't tell somebody what success looks like for them. So I wouldn't worry so much about like being a success is something that happens as a byproduct of doing good science. And you can choose, you have control over what kind of science you do, what kind of research you engage in, but success is sort of inevitable if you do good things. So instead of being successful, I'd like to talk to you about how to be productive. And again, once I realized that you know, that's the real important thing to discuss. And I started thinking back of different people I worked with and different, I guess, examples I have in the field, then I was reminded by this quote from Leo Tolstoy, basically, all happy families are alike, each unhappy family is unhappy in its own way. Well, that's not, to me, how it seems like it works in research. In research, it's that everybody who's unproductive sort of falls into some small, narrow sort of categories. But you can see from this left-hand panel that you can be successful in many different ways. The main thing is to avoid sort of common pitfalls where you just get stuck at one stage of the research cycle and you don't get all the way through to being productive or being successful. So mostly today I will cover topics about basically how not to be unsuccessful, almost how to not be unproductive. And to consider how to be productive then, so what does unpredictability look like? So what are the common threads that connect people who are not able to get science done? So first, you have to be well, you don't have to be happy, but if you're unhappy, it's difficult to do good science. And it's this negativity, it's almost like dominant negativity that you can sometimes sense in a group. And the people who possess it, they have difficulty finishing projects, they doubt everything. It's good to be skeptical, it's good to be questioning things, but dominant negativity, constantly undervaluing your own and others' contributions, it just leads to lack of productivity of yourself and others. So one way is just to not being unhappy is a way to reduce productivity. So arguably the most important thing to be productive is to produce something. So and to produce something to finish. So really the main limitation in being productive then is execution, finishing projects, publishing. And one way to do that is just to have lots of exciting ideas that you keep pursuing without finishing any particular one. And there are others, and I'll talk about those. You can also pick suboptimal projects. I mean, you can be good, you can be sort of happy to be able to do projects, but you do things that don't make sense. So an important part of being a productive researcher is picking the right questions that are tangible, answerable, and so on. And the last two are maybe not crucial, but they make sense to discuss. So one is to not be able to take opportunities. There are people who are able to keep executing some projects, but they don't really develop their productivity. They have one or two papers, but then they sort of get stuck. And sometimes that's just because they don't know, they don't have a vision of what it takes to either do the next step or like where the science should take them. And maybe they are just stuck in a skill set that is not really no longer useful. So there's an aspect of being able to grow, or more, I guess, for lack of success, it's inability to grow or inability to take opportunities as they come up and to integrate into the field. So finally, one easy way not to be productive is to try to please everybody. And it's a fairly important lesson that everybody will learn at some point in their science careers, that you can't please all the reviewers, you can't please all the people who give you advice. Everybody thinks that some other kind of paper is better to be written, some kind of other science is better to be done. And if you let others set the agenda, if you let sort of quick and urgent things control your timetable, then you just won't have time and you won't have the focus to get important, interesting things done. Obviously, then there's a counterpoint to all of these, and basically how not to be unproductive. And before I get to them, I guess I just want to highlight what I base the rest of this lecture on. So this is my experience as a researcher myself, but also just talking to a lot of people in different institutions. So I'm from Estonia. I grew up in Estonia, or in the Soviet Union at least. I went to school in Tartu. This is a wonderful gymnasium that you may be able to see. This is the town square there in the bottom, where you could have come as part of the brew, but maybe I get to come soon. I enjoyed sports, maths contests, something like that. I did my university degrees in 3 different countries, so across Estonia, the US, and the UK. And then did a PhD at Sanger Institute in the UK, where I also enjoyed some basketball and windsurfing and some other things. I did a 2-part postdoc, so first in Canada, or 3-part really. First in Canada with Charlie William and Renders doing yeast training screens. Canada has a great place, you can go axe throwing as a hobby. There's awesome nature. I spent some time in Embel Heidelberg with Lars Steinmetz in Germany, and Schweinhaxel and lots of hiking in the forest there. And then also some time in Stanford in the US, where there's all the Californian nature. And by now, I'm a group leader both at Sanger Institute in the UK and also a senior researcher at the University of Dublin. And most of the time now, when I don't do science, when I'm not at the computer, is to look after some chickens and some children. I think right now we have more children than chicken. But the basis from which I talk is experiences in 4 or 5 different big international research centers and talking to researchers there, and also basically from things that I've witnessed firsthand in collaborators and in colleagues, and some that I've tried myself. So, but still, this is a subjective view. I don't claim that this is the truth. This is just my view of what it's like for unproductive people to fail, or then conversely, how to be productive. So obviously, to avoid being unhappy, you should be happy. To not execute, finish, and publish, you should finish your projects. Instead of picking bad projects, you should pick good projects. And instead of failing to take opportunities, integrating, growing, you should be a professional and sort of understand the context in which a professional life takes place and how to be an effective member of that context. And finally, instead of letting others to have the agenda, you have to have control to be able to do what you think is most important. I'll go through each of these in turn. Okay, so and these are in the order of importance, by the way. So I think it's most important to be a healthy person. If you're not a healthy person, if you're not happy, then none of the other things matter. So by far, always your health and your mental health should come first. There are often during PhD sort of the dangers of burnout and so on. We'll talk a little bit about that, but you should always put your health first. So the way to achieve that is really to have some balance in life. So there is food and exercise, for example, and sleep that are crucially important. But otherwise, I guess being healthy, being a happy person, this is also something that's subjective, and the same method doesn't work for everybody. So, there are people who really just thrive on trying to be at the very forefront, being the fastest at doing science, being the first to build a method or a software or a web page for a particular new technique. And that's fine. If that's what makes you happy, that's fine to do. But it's important to figure this out for yourself. What do you need to be a complete person? What do you need to balance, or whatever it is that you do at work? And in general, a way to be healthy in science is to develop a set of resilience tools that allow you to avoid frustration. So stress and burnout, they usually sort of come from festering frustrations. And the festering frustration can often come from workplace relations, for which you should be a professional and deal with them. But it can also just be feature of science not going as well as you'd like, but that should not be an issue. So I was at the Lindau Nobel meetings, I don't know, 5-6 years ago now, and there was a guy, Edmund Fisher. So he's really ill by now, maybe 100 or so, and he got Nobel Prize in the 50s already for protein kinase A. So, well, he's a biochemist. And somebody asked him, so, what do you do when you get frustrated? What do you do when experiments fail and you keep failing? And this, 90-plus-year-old guy was just like taken aback. He's like, what do you mean frustrated? Frustrated with science? I don't understand. I do experiments. I have my controls. I know what I'm doing. If the experiments fail, I can look at the controls and see what failed. Even if I don't know, then I put more controls in. I repeat. Like I don't have control over what the world is like. So how can the outcome of an experiment frustrate me? You have a method, you test if it works better, it doesn't, okay, that's a new understanding, you write it up, you move on, you do an experiment. Like, at no point in that process there should be a space for frustration. And you can think of this also when you're sort of setting out to do a PhD and setting out to do a particular project. You have this linear view of the world in mind where you're at A, you know these things, when you get to B, you want to develop this method, to establish this approach, develop this website. And frustration is sort of the difference between reality and expectation. You expect that it's a nice clean thing. We start here. 1 week I do this, second week I do this, and within 2 weeks I'll have the project done, Nature paper published, and so on. And the reality is much more difficult, where you start going in a direction, but then suddenly you realize you learn more about the true complications of the project. You learn more about the subject matter, you know more about the true demands, and you sort of become into this uncertain loop. You do maybe some experiments, you learn a little bit, you do some more experiments, you learn a little more. It's not clear how to break out of that. But the important thing is to sort of keep nurturing the project and perhaps to support even new directions. So you don't have to definitely get to B. Maybe there's much more informative, better project that takes you to a new goal that's really worth getting to. And that's one way to avoid the frustration. So many of these pictures, by the way, are taken from Uri Alon's nurturing websites. I'm not sure if I have a proper reference in there for this, which is very professional. But if you search for this, then or I can also just post them later by the Brew mailing list. And the way to avoid frustration really is to sort of let it out in small doses early. So for example, it's just having lunch with the team to alleviate frustration, having extra peers at home or elsewhere with you can vent, the experiment didn't work, this sucks. And reviewers' response and so on. Really you can let off some steam and come back and externalize it. Like, it's not usually under control. And perhaps the most important thing that I've seen eating away at people is identifying with things that are not under their control. So, for example, you pick a research project, you want the world to look at a particular place. Like, you think there is something really cool hidden in this data set, but there isn't. Like, it's just, there maybe was some signal. It's not reproducible. It's really noise, or it's a technical artifact. And then your well-being is contingent on the world around you being in a particular way. In the same way about things like, I'm not getting reviewer reports back. Your happiness depends on what some random postdoc or group leader in Nebraska or Japan thought about the science that you have done. And they most likely are somewhat related field, but not exactly in the same field. So they have their own opinions, they might have an agenda, and so on. So really, their opinions are not under your control. So you should not identify with sort of the excitement of the results, which is not under your control. You shouldn't identify with things like paper acceptance, which is not under your control, or really any other kind of external evaluation. What you can identify with is knowing that you're working on something that you enjoy, knowing that it's an important question. For example, that people have been sort of studying this for decades or even centuries and trying to understand how the world works. You know that you have a good process, you have thought about these things, you have the right controls, you're doing the right things. And that's something that's under your control. You can take pride and solace in, there's nothing I can do more. I know the field, I have designed a good experiment, I've executed it well. Like, what else can you ask? And as long as you keep doing this, then what else can anybody ask of you? Anyway, so as a way to be a healthy person, if you're not healthy, it will weigh you down, it will weigh the group around you down, and it will hugely impact productivity, both for the short term, but also in the long term. getting back from burnout is very, very difficult. To avoid burnout, to avoid frustration, it's good to develop resilience methods. So if you're just sort of letting off steam, especially using sports and so on, but also just make sure you have a peer group with who you can share these experiences of doing science. And something that has made a difference to me and also many others is to identify with the process, but not the result. So what you have control over is the process, and you can take pride in it, you can optimize it, you can do it as well as you can. You can't control the results. Even if you do the best science, you can't control that. We know whether, what was a nice example lately, that the DNA alternative to CRISPR, like basically people really want it to work. You have DNA-guided DNA editing. Like it was going to be the next Nobel Prize, but it turned out it only works in bacteria at 50 degrees. It doesn't work in human cells ever. So, it's just something that's not under your control. This protein unfolds. So focus on things that are under your control, and also don't get discouraged by things that are not under your control. They can be annoying, sure, but in a way you can think, okay, this is the state of the world right now. I can react to it. I can think what I should do next. Okay, so basically be happy by avoiding this buildup of frustration, and that's by basically having at least some kind of balance, and for sure being healthy, and not identifying with external rewards. The most important part then, if you're a human being who should be going to work, if you're sort of so out of it that you should be working, then everything else doesn't apply. If you're in a good fit state, you can come to work, you can do things, then the most important thing to be a productive researcher is to get things done. It's to finish. And to finish, it's worthwhile reflecting that everything is a project. So everything that you do in a research setting falls under some project. And you might as well right away know that and then file everything you do under a project. And then given you have a list of projects, you can then prioritize them, you can rank them, you can sort of time slot them so that you have control again over how you prioritize and how you execute. And if you have a project, then there's sort of a set of tools that you can use for project management, and you should be consciously managing each project and executing. So first, what does it mean to have a project? So the most important piece of advice, the most useful thing that I know about being productive in science is to treat everything with a project for which you know the criteria of success and failure. It's very difficult to, it's very easy to have scope creeping project where you just keep expanding in different directions that are all kind of cool. We could add this feature to this program, we explore this extra data set. It's very easy to keep trying more and more things in a linear way of, what if we try this as well? What if I try this as well? It's also easy to keep trying to fix things that maybe shouldn't be fixed. Okay, this didn't work, what about this? And this kind of scope creep and lack of finishing usually comes from not giving enough thought up front about what does success look like and what does failure look like. So once you start on a project, it should be the scope that's well defined. You know what's in the project, what you're going to do, but also what you're not going to do. And for big projects, it's sort of a little bit more complicated. For small projects, if you have a milestone, you know when you reach it, and you know when you can't have reached it, and what the stopping criterion is. So for a bigger project, I would scope the milestones. First you need to establish that you have data, or for a wet lab one, you have a protocol that works. Then you know what kind of analysis you want to do on the data, and then how you want to cross-validate them, for example, cross-checking and stuff like this. And you could just realize right away that these data suck. That's it. That's the end of the project. You don't. If you decide to use another data set or something like that, then that's a new project that you scope again. And in the same way, you do some analysis. You're looking for an interesting signal. The signal is not there. That's it. That's the end of the project. And you should go back to just your entire project portfolio and reevaluate. Okay, I have all these things going on. Should I now take up a new project that takes another data set like this and tries another approach to this problem? And quite often the answer actually might be no. That If it doesn't work like this, I don't want to spend time doing this. So it liberates you to split the past from the future. So, everything it's sunk cost. Everything you've done is sunk cost, and you only have control now over what you do in the future. And it helps to quite often declare projects closed so that you have kept bandwidth going forwards. So you can choose whether maybe I don't want to do this anymore, and that's fine. You should be able to let some projects die. I mean, that's one of the ways in which people fail, is that they keep carrying on their master's project through like 4, 6, 7 years. And it's clear that actually, that question that they originally asked, it's not relevant anymore. Yes, you might have the data set. Yes, you might only need to do like a couple of more extra types of normalizations, but it just doesn't matter anymore. So at some point you have to let some projects die. So criteria of success and failure, when do you stop? So we'll start with a milestone. So say that you have a project in mind, you want to answer a particular question. You have some milestones. I want to do this first. If this works, then I'll do that thing, and then finally do the third thing. So often, every milestone is an answer to a question. Are the data good quality? Does this method work? So the next thing is to frame the milestones so that, so I found it useful at least to frame the milestones in a way that the answer is a plot. And there's one axis of the plot that's your sort of free variable that you have control over, or whose effect you want to explore. There's a y-axis, which is your observation that you want to assess. This can be different methods and running time. This can be whatever GC content in the DNA and frequency of promoters in there. But basically, you assess the dependence between a free and independent variable. And visualize, just think ahead. I want to ask this question: what does the result look like? What is a convincing result, or whether there is an effect or there isn't an effect? What does that look like in a plot? And usually it's a 2D plot like that. If it is not 2D, then it's more tricky, then it's maybe not well enough scoped, the milestone or the project. Because you can't give a simple answer. Is there an effect or not, or what's the effect size? So good questions for milestones for projects are usually, the answer is a number, and then you can then make decisions based on the number later. The answer is a number. That's a sort of physical quantity. That's an intuitively clear thing. The answer should not be a score. It should not be a p-value, because p-value combines both signal strength and sort of measurability. But ideally, a sort of biologically interpretable quantity in the bioinformatics sense at least. So yes, so a good way to set a milestone is that I want to have this plot. But once you have that plot, then you also have to do the extra due diligence and making sure that you understand what's in that plot, and that whatever that plot shows is real. And that's just having lots of extra plots to make sure that, if I switch these parameters around a little bit, it doesn't change. If I change the data set a little bit, it doesn't change. If I normalize differently, it doesn't change, and so on. So basically, there is a core answer, something that you put into paper as a figure, main figure. This is my effect. This is what I see when I poke on this axis and observe on this axis. This is the change that I see, and then you have done the extra work and it's not due to boring factors. Like, it's a real thing. So this is a good milestone. A good project is the one that answers a big question. A good milestone within there is something that produces a good measurement, a good comparison. So, and more computationally focused, like this all previously worked already for wet lab projects as well. For more computationally minded, you can talk to senior lab members in your teams and ask them about sensible project structure. For example, I already, after tens of years of coding and so on, I sort of know how I do data analysis projects and bioinformatics projects. And I don't force this on others, but I've shared it before, and it's really helpful to know if you take on a project, if you take on a milestone, what that looks like. And for me, it's always, I get a fresh piece of data and I just do exploration on it. What's in that data? Like, what do the outliers look like? If I filter those out, what does the data look like? What are the main drivers of variance? That's the pilot stage. After that, we usually talk to the data providers. Does this all make sense? Like, is this what you measured? Was this what you were looking for? And if that's all checks out, basically that milestone is complete. It can even be a project in itself. The project is complete, then we decide, do we do now a main analysis? Basically, do we take this project forward and sort of commit to almost making it a paper? So then we do the main analysis. So basically import from the previous code base whatever is useful now. Like, not everything in the pilot is useful in the main analysis. And again, we do the main analysis, we get the main findings. And then by the time we have lots of main findings, we start writing up a paper. And during the paper writing again, we pick and choose what do we put into the final manuscript, and we clean up the code to do things for it. And then actually during the paper writing, if you've been through this process a few times, then you know that there's a fair bit of change still. Like you think you know what everything as you go in, but as you write, you get new questions and you want to expand on some of the analysis. So actually during paper writing, there's another iteration of creating code. And only then, once you've done everything and you know exactly what's going to be in the paper, you finish the figures, you finish the text, then you clean up the code once more to have a clean set for publication. So basically, you keep iterating and remove, not including things that you don't use, so that for every stage you have a minimal required code base. Because otherwise, the extra chunk that you import, it weighs you down. You have to think of, you know, how do I engineer so that I can still abstract the previous things as well. We don't actually use those anymore, so there's no need for it. It's much quicker, at least in my experience, to refactor almost completely. And instead of trying to abstract, basically again, call that pilot project as a pilot project. It's a different project, and actually copy paste instead of import from there, because you most likely don't need all the complexities of that initial one, you know, the different types of file name handling and so on. Just clean it up, clean your input data up, and then refactor and have a clean version. And this at every stage. So in general, the approach that worked for me in executing, finishing, publishing was a getting things done approach, which basically involves a lot of lists. So there are books and sort of websites dedicated to this, and I don't want to go through it too much, and I'm not sort of a fanboy of it. It's just something that worked for me, that I enjoy knowing the structures of everything. I have lists, you have sort of strategic vision lists, like in the world, what do I think is missing? For everything that's missing, I have a strategy, you know, how would I go about filling these pieces? And for each of the strategy, like if I think I know how to fill a piece of science, so how would I go about this? So what would be the projects? What would be the experiments? What would be the analysis? And roughly these correspond to projects in our lab, for example. So I have lots of lists. I have lists of projects. I have lists of bigger items. I have lists of people, lists of grants, and so on. And having lists allows me to ignore them. So I know everything is in a list somewhere. I don't have to think about it. And all I have to do is focus on the project problem at hand. And to me, being able to focus, giving attention, undivided attention to a project, that's what doing the science at its core is about, to get deeper, to get more understanding. And that's really difficult to do if you don't have the bandwidth, or if you have many things going on at the same time. Basically, I recommend the getting things done just because it allows you, again, externalize worries. You can only focus on one project at a time. Then we review them regularly on like a weekly basis or monthly basis or yearly basis, depending on how course-going they are. So this is about executing a project. You have a project, you know that you want to do it, you scope it well, you know what's in it, you know what's outside of it. Once you know what the sort of success looks like, then you set milestones. You first I do this, then do this, then I do this. And for each milestone, ideally, again, you know exactly what success looks like. You know, I have a plot like this, or I have a table where the rows are the different entities I care about. And so we have a tidy version of it, and the columns are the observations. And once I have that, I'm good. And to get, it takes a few tries to get a good sense for what the good chunks are for projects and milestones. And then also, it's good to then have a structure around it, that you have a coding structure that you can use from the start. And you can basically talk to your old colleagues about this. I think you only need something that works for you. Again, it's a very personal thing. Some people use Eclipse for everything. Some people use Trello and other project management software. Some people use Notepad. Some people use email. It doesn't really matter. Like, you just have to have a way of doing it that works for you. And then for me, that was sort of getting things done, inspired approach. Okay, so if you can execute, the most important thing by far is to finish. Like, if it's not finished, it's zero. Like, having 5 projects 95% done, it's still 0 projects done. It really doesn't matter if it's not finished. And so, and especially for sort of students, as I recently found out, especially, it seems like there's a tendency to be extremely careful. Again, so it's almost bordering on the negative, where you've done things, but you want to be completely protected against any potential review or comment. You know, like, what if the reviewer says this? We should definitely do this analysis first. That's not really how how it works. Yes, it's important to sort of be honest about what you don't know, or be honest, open about what you haven't done. But it's more important to be sort of confident in what you have done. So one thing done confidently is better than having something done and sort of protected really well, if that makes sense. So basically, instead of trying to plug every hole, it's to make sure that the main thing that you present is convincing. So one good thing, well convincingly done, is more important than having covered every possible extension, every possible negation to a small result somewhere else. So avoid perfection. Once you're confident, and confident by combining data and evidence from multiple sources, that the main claim that you want to make in a project, in a publication, is true, or at least you're sort of willing to stick your career on it. I mean, it's time to finish. It's time to write it up and wrap it up and move on. You don't have to be perfect, but you have to be confident enough to move on. So publications add value in sort of one core thing at a time, done well. They don't add value by trying to do everything. That's, you have some review papers that might want you to have breadth, or you have some method comparison papers where it's the game is slightly different. But in general, there is sort of one core contribution in every paper you can think, and once that core is there, everything else is sort of seasoning around it. And as soon as you have that core in place, you can start thinking about writing and publishing and finishing. Yes, there will still be things to fill in along the way, but at least, again, you know what the success looks like. I have this plot. This is my plot. That's it. And I'll talk a little bit about publication as I asked to. You can also say that finishing is good, but really you need publishing. If you didn't publish, it didn't happen. But the preprints have really started to change that a lot, and they also allow you to have control. So I love them. I love it that once I finish a project, I can publish the preprint on the preprint server. And then, that's the end of the project for me. The rest is just to satisfy reviewers. And I don't really care too much about that as before. Like, these are just some random two guys who have opinions. What we wanted to say, what we thought was important to convince, we already put in the paper. So from my perspective, things are done at that stage. But still, you need to make it available to others. You need to make it accessible. Okay, so I covered the most important things in being productive. So one is to be healthy and happy, so that you can be a human being who actually does science. The other is to get things done, to finish. And okay, so what should you finish? What are the kinds of things that are worth doing so that you're a successful, productive researcher? So the next important thing is making sure that you do good projects. And that's, again, you could argue that's subjective, but I think there are more things to say here than about, for example, scientific success. This is again from Uri Alan's website, or actually editorial somewhere in MSB maybe, where he discussed what makes a good PhD project, or just a scientific project in the lab. And I really like this idea that, you have at the top left, you have talent. So this is you as an individual. You're strong in some things. You have a degree in a particular field. You come in with things that you can do well, better than 99% of the population. Then on the right, you have things that you care about. You may be able to do really good coding. You may be able to build some deep learning models. Maybe text algorithms. On the passion side, you care about art. You care about literature. You have DNA, RNA, coding RNA, non-coding RNA, short RNA, long RNA, in humans, in mice, and so on and so on. Do you care about health and disease? Do you care about cute critters? Do you care about really random things? There are many passions, and these are completely subjective. The talent you can be quite objective about. You know what you're good at. Passions, that's subjective, but at least you also should know why you want to do particular things. And that's worth exploring. Like that, really, if you don't know what you're excited about, then that's worth spending a lot of time thinking about. So you find a project that can really latch on to. Then you overlap that with the objectives of the lab that in which it's situated. So the good project should really have elements of all three. It should be something that you're good at and excited about, but also that the lab finds useful. So that's really a neat way I found to think about a good project. So that's quite a sort of meta consideration, but what does an actual good project look like? So I work mostly in genetics and mathematics and computational biology, and a good project nearly in a lot of ways. I don't know good projects that don't answer questions or provide new methods and tools. So there should be a gap in what we know about the world and are trying to understand about the world, and a good project fills a gap. It can also be a gap in technology. Like we want to be able to do something in the world, but we can't, and technology enables this. That's also a good project. So that can be both for statistical methods. We want to be able to estimate differentially expressed genes from RNA sequencing data, and we can have a solution to this that then enables people to do that. Or we could say that I want to be able to do this, but I also don't want to command line. So then you would have a nice web tool to do this for you. And again, people close these gaps in different ways, and we have different ways of being successful. Answering questions. That's maybe call these people computational biologists, like Kaur. I'm not sure if he talked to, he answers questions about gene regulation using large-scale data sets, and plugging gaps in understanding how genes are regulated between individuals. If people who build methods, so maybe Meeliskull is an example of that, where you have a model that is sort of best in class for extracting a particular piece of understanding from an existing data set. And methods can be quite data set agnostic. It doesn't matter if it's, in some cases, even if it's biological data or not, or if it's biological data, if it's mouse RNA-seq or human RNA-seq and so on. So you have a method that does a really good thing, or a tool that, Yakuoscope is famous for building best-in-class software for particular tasks. So there are many ways of being successful here as well, but the important thing is that these things should matter. You should change how people do things. The results, in Kaur's case, they change how people develop drugs for disorders. For Meelis' case, how you would calibrate self-driving cars, uncertainties for whether there's a pedestrian in front of them or not, or whether thousands of people use Vila software for analyzing their gene list and so on. So in a way, a good project fills a gap, and gap usually, again, that gap should be in the intersection of talents, passions, and objectives. You should care about this, but ideally it sort of matters to others as well. If it's something that doesn't matter for others, you could say that it's not in line with the objectives overall of world science, then it's talent and passion. That's more like a hobby. So it's an okay project to do on your own, but if it doesn't matter for others, then it's a good question whether public money should be spent on doing it. And then you have the other sort of parts of the Venn diagram. If you have a talent and have the opportunity or objective to do it, but you don't really care about it, it's not clear if that's a good project. You could be good at doing data analysis or coding, and you're in a lab that requires that. But if you don't care about this, you're not going to be as motivated, and is that worth spending your precious minutes of being alive on? And then you might have something that you care about and you'd like to get done, but just don't know how to do. Your computer programmer was in a wet lab, and they're really trying to understand how the malaria parasite invades and what drugs could restrict that. But if you don't know how to do the experiments in the wet lab, it's not really a good project for you to propose this. So it's important to keep these three axes in mind when choosing a project. But I still think that by far the main criterion is to fill an important gap, a gap that others think about as well. So once you've identified a gap, it's not yet clear that it'll make a good project if there is no data to fill that gap. So if you can't generate data yourself, you require external data. It has to be a fillable gap. You could say that we don't understand the origins of the universe. I want to fill that gap. Yes, it's an important project. Yes, you might have a talent and passion for it, but it may not be an achievable project. So it's important to assess whether you're placed in a way to fill that gap. And usually it's good to have a broad network. You have to know the field, you have to network in conferences, have collaborators, just to be aware of where things are in the field overall, and then have the knowledge of when data becomes available to fill that gap. So basically, it's in general good to have lots of gaps in mind and see when data comes available. So once you've identified a gap and you think that you can fill it, and you can still evaluate whether it's a good project in terms of scope and complexity. So here, for example, there's a more from Urialan, where on the x-axis is the difficulty of the problem, sort of going towards easy, towards the right, and importance, let's say, on the y-axis. So basically small gain in knowledge to the bottom and large gain in knowledge from the top. So these ideal projects will be easy and important towards the top right. And these are rare, let's say. Pointless projects are on the bottom left. So they're hard. Yes, you might get a good sense out of being able to do something that only you can because it's really difficult. But if it doesn't matter, it's not a good project. So you have these projects that give you a large gain of confidence in knowledge that can be quite hard, and also ones that are easy but maybe don't give as much. But also it should be clear from this plot that there are sort of projects that dominate the others. So basically anything that's directly above or directly to the right dominates the ones that are below or to the left. So that's worth keeping in mind when choosing a project. And especially for computational methods development. Another way to think about this is to think of the sort of speed and contrasting the speed and the fraction of the problem solved. It's good to be the first who solves, I don't know, even 50%. We put here 7% of the problem. The first to see some kind of data, the first to propose a method for it, regardless of how good or bad it is, people will use it and they will have to compare against it because of the first. So then it's good to be fast and to just do a reasonable job. There's also value in providing the solution. So basically you make a big iteration where you remove most of the remaining uncertainty. So for example, you go from sort of 70-80% where you sort of do something reasonable but it doesn't quite work yet, to 95 to 99%. So in the initial iteration from 0 to 60, so you remove, let's say, 2/3 of the remaining uncertainty. So removing another 2/3 of the remaining, that's a good level of a project where basically you could almost say that this problem is now solved. Like any remaining improvements are really marginal and they won't change what people do in practice. So it's important to avoid then in the unsuccessful cases is people who get stuck somewhere in between. You're not early enough to do an easy thing, and you don't solve enough of the problem to consider it nearly solved. So things like, if you now went in trying to again push something like DSEQ2 for differential essentiality estimation or another G profiler, there are nearly complete tools out there. You don't need another one. And if you only take a fairly well working solution, like 70% working solution, and it is slightly better, but it's still clear there's a huge gap to what you really want to do. Also, you could probably publish it, but a better project would be to try to understand all of the remaining problem setting and solve that. So these small increments like 95 to 98%, that should be then at least 99 or 99.5% to make it worthwhile. So the best optimal projects change as you move through your career as well. So as a student, it's good to start off with something that's sort of tangible and it will give you a result. So towards the right and towards the low. So basically maybe not so huge gain in knowledge, but it's doable. Like you don't get stuck for 4 years and with uncertain chance of success. You start off with something that you can get done. You can maybe get done in half a year. Finish it to get through the entire process from the sort of conception of the idea to finishing, publishing, and then you iterate, and then you can take a bigger jump every time. So then, a good problem for a postdoc would be something that, it's not easy and large gain of knowledge, but it's somewhere there towards the top right where it's ambitious and sufficiently hard that you require a PhD almost to get it done. But it's not something that you require an entire institute for, but it's something bigger than you would do as a PhD student. And sort of top left then is large gains of knowledge, but they're difficult problems. So that's where you need multi-year planning and large research grants and either groups or institutes working on it. And usually those are then broken up into many individual projects that each do a small step towards incremental knowledge. And so good projects, basically you would want to fill a gap in understanding, gap in methods, gap in tools that we have available to make sure that the gap is fillable, like that it's a reasonable thing to do, that you don't sort of just chase after wild dreams that cannot in principle fill them at all, and have appropriate scope. So basically it's an important gap, it's a fillable gap, and you can fill enough of that gap. So it's not just to fill you know, 10% of the 30% remaining, or 5% of remaining 15% remaining. You should fill at least 2/3, maybe even 3/4 of the remaining gap in understanding. And once you can do that, then a good project, I'd argue that you also want to keep moving. And that's something where, again, some less successful people, less productive people, sort of gotten stuck. And I don't want to say that they don't move with the field, but they get bored themselves, and their contributions become less appreciated as the field just moves away. The successful people, they keep moving, they keep thinking at the forefront of the field, and they keep proposing new ideas. Like, for example, it's also in painting. This is a more classical painter that then goes on to explore different styles and different techniques. And Picasso basically trained as a classical painter and went through all these phases before and after Cubism. So there is somebody that basically never stopped exploring and never stopped moving. Just important to, if you're really passionate and want to be productive in science, to keep invigorating that thirst for understanding, really. So I think this is useful meta discussion. So, how do you pick good projects in general? You should pick a gap and try to fill it, and then do enough of the filling. But then how do you know where's a gap? So how do you choose a good question? I think there is no way around just knowing the field there. As a starting PhD student, you have to trust the supervisor a little bit, say that, here is something that's worth doing. But then you should read and make sure that that's actually true. And then as you read more and more, you learn more and more, and you know more than a supervisor, and then sort of break the sound barrier and take off on your own. So the way to know the field is first to read. Like, there is no substitute for it. You have to put photons into your in your biological neural network to shape it in a way that results in your field are no longer surprising. Basically, you should have a mental model of what the field is like and what is happening. For example, I set aside Friday mornings, sort of 9 to lunch, just to read and think. And that hopefully is enough to cover the main journals and abstracts. It's to think about the field that I currently consider for that day, and what's interesting there, what's important there, what's answered there, what's not answered there. And it's useful to read a couple of reviews every now and then, and sort of from major people in the field who've been there for a while, and they write, like, there's annual reviews in genetics and genomics and things like that, where sort of senior people write impactful things, and they usually give a fair overview of where things are. But at the same time, it's so exciting to read ancient papers. So maybe that's something where you could have an age over the others, where people back in the day, they didn't have so much literature to read, let's say. They didn't have so many resources available. They were forced to think more. And there are lots of ideas that are, there are lots of cool papers that are full of ideas that have sort of gotten second wind later. The coolest example I recently saw was somebody who was going through a 19th century manuscript on different types of blood. So basically, there was like an abattoir where people were killing different animals in Britain. Like, you have deer and venison, and cow, sheep, badger, and so on. And they noticed that the deer blood every now and then was, the blood droplets had different shape. And basically went back and realized nobody understood quite why that was, and turned out that there was a particular blood deer parasite that wasn't really well appreciated. And there was a sort of successful line of research that had quickly medical implications as well that stemmed from it. And all because of sort of a photograph in a 19th century manuscript. But even just knowing your own field, knowing what the origin of the research field that you work in, and knowing the core founding papers and what people back then thought about and how this field would develop. And you can think, okay, well, we've gone through this branch now when we start doing genetics, that we're doing, for example, that we're doing these genomic association studies, but it's not how people started off. Like, what happened to family studies? What happened to just doing mutagenesis and like taping seeds to nuclear reactors? Like, why don't you do any of that anymore? And then sort of keep asking questions and keep filling in the details and just know the field. And the way to structure reading is usually good to have depth in your own discipline. So, for your introduction and discussion sections in your papers, you need to know your field, you need to know what's done. You can't have any surprises. You can't have somebody saying that, wrote this paper, it's already solved this problem. Like, that shouldn't happen. But also it's good to just read broadly, and like you have these passions in the 3 Venn diagram part, you can just read around passions. What's happening in the fields? What's happening in nearby fields? What kind of techniques are becoming available? What kind of compute can you now do? What kind? Well, use Reddit, Hacker News, whatever. It's all sort of part of professional development. So keep moving and progressing productively by reading interesting things. And again, maybe this doesn't surprise you by now, but I also encourage to keep some lists. So there's a guy in Stanford, Kevin Sherlock, who I asked him, how do you fund your research? And how do I fund my research? Well, I have a list of ideas. When I run out of money, I pick one from there. I write a grant, I get money, I do the research. Like, again, because of incredulous. But in general, it's I don't have ideas that often, and once you think them through and they're still reasonable, it's worthwhile not losing them. So a lot of people have a single file with lots of ideas in the list, and they can then every now and then go through and sort of delete things that don't make sense. But at the same time, just keep looking at your ideas and saying, maybe now is the time to capture some of them. You also keep a list of questions that you would like to understand but don't have answers. What's my favorite right now? How come that children who have developmental disorders, they have mutations in genes that are known developmental disorder genes, but they're not diagnosed with that because their parents also have it. So somehow the parents have a developmental disorder mutation that should really give them severe defects, but they don't have it. So what is it in those parents that's protecting them against that effect? And then you can keep sort of an eye out and ear out for people who are trying to address that question, and keep informing you about that. Just to think of, I have a question, what kind of data set would I like to answer this, let's see, for example, is there any link between GC content and promoter positioning in humans? And, you can think, oh, okay, finally, somebody has a data set where you have 1 million humans and the variation in GC and CpG methylation, for example. And then they've also measured chromatin conformation between promoter and TSS and the strength of the TSS. And, maybe this is the data set that I need to answer my question. Basically, if you think of a question, you can also think of what would be a data set that answers that question. And you can then look, is that data set there? Okay, it's not, fine. I can't do anything right now. So, you think of a good project idea, there's a gap that you don't understand, but the data are not there. So, you just don't discard that idea. You keep it as a project idea, but just note that, if I had this data, I could address this question. So basically keep an eye out for these kind of data sets. And same for dream method, I would like to answer these questions. There's no data for it because, well, there's nothing that would generate these kinds of data. I would like to understand the evolution of all species on Earth, but we don't have that kind of sequencing capacity. But then eventually, the sequencing capacity comes online, and you can start answering those questions. Something like, back to Feynman, who had a similar thing of, they have a bag of tricks in their mind, the kind of things that we could apply. You could have your own toolbox. You also have a bag of problems, these are the kinds of problems that are still annoying me. I really can answer them better. So every time you learn a new problem or a new trick, basically you try the tricks on the problems, and you see if any of the tricks work on it. And the same way here, you learn new data, it's like, okay, do any of these data help me inform about the things that I really care about? Or if it's a new problem, okay, do any of the existing data sets and tools that I know of, do they help to inform these data, these questions? Yeah. And the same way, this is more about professional development, but just keep an eye out for dream opportunities. So what kind of things you would really like to do, an internship here and there, a job somewhere, just keep a list of things you'd like, And so it's one thing about just reading, getting to know the field, that's literature in the field, both current and ancient, both sort of in-depth in your project and broadly. And then maybe keeping annotated lists of the kinds of things you'd like to do, the kind of questions you have, the kind of tools and data you have at your disposal. But then the field that you work in, it's actually a living, breathing thing. There's no science without scientists. So the way to really become a part of the field, that you know what people are really thinking and discussing, is to go to conferences and talk to people. And the best way to do this is maybe at poster sessions and just arguing. It's to have your way of how you think the world works, and then just challenge people who think differently. It's like, you think this, but I don't think this consistent with all this data that we're seeing. So what do you think? And it's always, if they are reasonable scientists, they will engage in discussion, and you can learn a lot about each other's positions, and maybe there's sort of a fruitful intersection there where you both agree that there's uncertainty, and it'd be worthwhile to reduce that uncertainty by a collaborative project where you provide methods, they provide data, and you can just look for answers for a discrepancy of opinions. So I think it's fair to say developed lots of interesting exchanges and maybe even a few collaborations like this. Okay, so you're a happy researcher who can function as a professional. You know how to scope projects, to execute them, to finish and publish. And you know also how to pick a good project. So what's left, I mean, these two last ones are then, if you can do the first three, then you're already a productive researcher. But there are ways to make your life even easier. First, to be a professional, and then it's just to keep growing. People who don't know how to write, people who don't know how to give talks, people who don't know how to manage projects, they just have a handicap compared to everybody else. Basically, don't put yourself in a disadvantage. Just know how to execute the professional parts of your job as well. Keep building your core strengths so you know what you're good at, you know what your talents part of that Venn diagram is. And that's sort of your competitive advantage, and you should keep growing it. Just because you did an undergrad in probabilistic modeling doesn't mean that you can do all probabilistic modeling already. You can keep learning about automated inference engines, Stan and PyMC, Edward, and so on. And then one way to shape that growth is to, usually you have, at least in your stage, you have milestones. When your current contract ends, when you have to get a next job. At the end of a PhD, end of a postdoc, end of a first sort of pre-tenure review, for example. You can think of what kind of CV do I want to have by then? So you can set sort of 3-4 year goals and then break those up into smaller ones and then work on them. I would like to have 5 completed projects, 2 of which are modeling, 2 of which are software engineering, and 1 is more biological, for example. I would like to show that I would like to know how to build deep learning models using Keras and TensorFlow. And basically, I want to have all these things on my CV, and then you can look for opportunities to put them there. So pre-build that CV and then fill it in with actual things that you do. So as a professional, it's important to be a good colleague. And this is it's getting a bit vague, but you can just be a nice person. And to be around, and this helps. Basically, if you're an asshole, then again you're holding yourself back, because people who you depend on for success, they will not help you. But also, you shouldn't be naive. If you're nice, there are also going to be people who have their own agendas, who want to take advantage. So it's important to be nice, but just not let yourself be walked over. It's good to be collaborative, both for knowing where data are around, knowing what kind of ideas are around the world. It's very rare that there is direct competition in exactly the same thing. So even if you have 2 people who work on a similar topic for a couple of months or years, they usually have different approaches, and it's almost always better to compare and contrast and sort of do something together than to sort of try to compete at all costs. I think the false positives there are much rarer and much lower impact than all the false negatives that you lose out on. For example, I think every paper that I almost had from my PhD was scooped by somebody. 3 or 4 from the same group, a couple more from another group. And it's okay. We all got our credit. We compared ultimately against each other. Effectively, it's a replication of each other's work. It is fine. So it's better to collaborate. And then to get and give feedback. Again, you depend on your colleagues for honest feedback, and you should give feedback to others as well. And again, you learn about their work, and you grow as an individual and a professional. So, okay, so 2 ways that people have sort of gotten stuck in their productivity and careers are failing to grow and work on their strengths, to keep building themselves into better versions, and to basically be an asshole, basically not helping others, not collaborating, basically ignoring requests of feedback. Slowly but surely, this sort of builds up a resistance against you, maybe in the department and elsewhere, where you just don't get things done easily anymore, and it's going to hold back your productivity. And maybe most importantly, just if you don't make the career steps, then also your productivity will eventually, if not go down, but at least you can't increase it anymore. the way to be productive, to make career steps is just to be aware. I think the last bit here is most important. It's not about knowing the game, but it's knowing what the trajectory looks like. What are the awards available? What are the fellowships? What are the deadlines? If you want to achieve something, when should you be thinking about it? You should know those timelines. You shouldn't have this list of dream opportunities. As I finish my PhD, my dream destinations are these. It can be a mix of industry, academia, others. But the earlier you know them, the better. This will help you grow your CV or pre-build your CV. It will help you basically plan ahead. And it's obviously good to develop a support network, both of friends and of peers. The most important part of a piece of advice that I got from friends who do MBAs, so Master of Business Administration, is sort of on networking. So I hate the word networking. I don't do well at conferences of just trying to go and talk to people, but it is hugely important. For instance, looking for postdoc positions, I sent out maybe 10, 15 emails to people around the world, asking to I like the research your lab does, can you talk? Maybe I'd like to come for a postdoc. And I got 3 responses. And those 3 responses were from the labs where I had talked to the person at a conference and followed up. If I'd only talked and not followed up, they didn't remember my name. If I hadn't talked to them at all, they didn't even bother responding. But the 3 people that I talked to and I followed up over email after the conference, basically I went there to visit, and I got offers, and I ended up working in 2 of those 3 labs at some point. So the way to network at conferences, first, it's not a dirty, sleazy thing. It's just a professional thing to do. And it's simply about sharing your interest in science. You have a common interest in what's happening, and you can just go and ask a question. So what do you do? What do you think is the most exciting thing happening right now? What do you think is the most exciting talk at this venue? Where do you think the field is going next? I read your paper about this, tell me more. And people are also there to do the same thing, so you shouldn't feel bad about it. And the crucial thing is, after the conference, give it 1 or 2 days, and then email individually to everybody and refer back to the discussion you had with them, say that you really enjoyed it, and sort of throw in a few more ideas, maybe almost. Maybe you can start a discussion. Most of the times you don't, but these can go into quite interesting scientific discussions in their own. If you establish a new colleague with who you'd like to discuss science, that's a really useful thing in itself. At the very worst, they're now a good contact. You can email them and, hi, this is Leo from the Biology of Genomes conference in 2008. Remember we talked about this. So I now want this. Basically, it's a difference between those people listening to what you have to say versus ignoring your email from the outset. Okay. So to be a professional, keep growing as a professional in the field. Don't be an asshole, be a good person, and just don't fail to play the game. I guess make career steps, just be aware of what it takes to take the next steps. You don't have to optimize for sort of smooshing up to all the big professors in the field and so on, but just, don't, again, leave yourself a handicap for not taking the opportunities that you have. So finally, there are people who can get lots done by having a fairly haphazard approach for everything. But again, I find it easier and reduce stress, easier process if you have more control over your time process. So what do you mean control? First, it's control of time. So you should pre-plan your time. If you let interruptions dictate what you do, you're not doing a good job. You should be able to focus on what's important. Yes, there are times in the day where you just need to handle emails, but that should be sort of filling in the small gaps. They should not be the sort of core purpose of what's happening that day. I guess ultimately it's all about finding a way of being productive that works for you. You can be a morning person or an evening person. You can work well with the Pomodoro technique of sort of setting 20-minute goals. Maybe you like to focus for 2 hours. You should figure this out for yourself. Part of the PhD is figuring out how to be a good professional. And then once you find a routine that works, either you track yourself or set a good deadline or whatever it is, and then stick to it. And focus on the big important goals to begin with, and then let everything else trickle in. If not yet, then soon you will have more demands in a time than you will ever be able to do. And you have to focus on the important to remain productive. And the way to to focus on the important is to say no to the unimportant things, or even just ignore them. So it's okay. Basically, you should say no. You should learn to say no, and it's okay if people are disappointed. So one thing then is to control the time. So we have a limited number of hours, working hours every week. You should have control over what you do during those hours, and that they are dedicated maximally to the important things. Next, it's like, how do you fill those hours? So you should control the process. You have control over how you do your science. You can focus on one major project at a time. So this is the next one that you'll finish. Next one you'll deliver. Next one you'll make a push on. You may not publish each of them. Like, it may just be a pilot project after which you assess whether or not it's worth continuing. But you know what your priority is, and you know that you're not going to shift and jump between them until that is finished. One project at a time until completion, and then switch. As before, control the process. You know when you stop the project. You know when it's done. You know when it's successful. You know when it's failed. So it's simple project management, but it's extremely important. A lot of people fail by just letting random amounts of the calendar take over the time, or letting switching between projects so much that they don't finish any single one of them. So you have to finish there. You have to avoid project and just push it over the line and be done with it. If you really need to clean things up later, you can do it once the paper is accepted. And maybe less appreciated is that you should control the environment, and that's what helps you stay happy and a good person. So one way to do that is find a good lab. So find good people, find positive people, not toxic people, no assholes. Ideally, people who are excited about similar things as you are scientifically. It's better to work with good people than with bad people. So that's another thing to control in your environment. Again, your being is shaped by the input you get from external sources, so from your eyes and from your ears. And if that's being filled with low quality material, then your neural network will also be less finely tuned. So the better the quality that goes in, the better the output will be as well. Maybe most importantly, that I've seen things that people vent about the most. So, I have a fair amount of peers from these different institutes of the world, make some friends everywhere and discuss what doing science is like. And most of the frustrations, or not frustrations, but just the things that you want to relieve anger about is about people. It's not about science, it's not about data, it's about people. And the types of people that people vent about are assholes. So assholes are toxic people who sort of either bullies or simply dominant negatives, or that basically take the joy of doing science out of this process. And it's important to know them early, to identify them early, and then to avoid them. It's not worth trying to change assholes. They are what they are, but really consider not working with them if at all possible. You don't have to collaborate with everybody. You don't have to do every project. Yes, it might be exciting, but then you're stuck with having to deal with just toxic people. And it's, more often than not, at least in my experience, it's not worth it. Also, time things. So basically, there are also people who are just maybe not purposefully bad, but they're low quality, that they need so much input that they take away too much time. So that's also sort of, you can think of people like a project in that sense, that you can say this project is now done and we don't work together anymore, and that's it. So again, keep focus, keep control over who you work with. And as I discussed earlier as well, as just under being happy, control the rewards, avoid external rewards of motivation. And the way to do that means maybe also during a PhD to explore what kind of rewards motivate you. When are you happiest? Is it internal and external rewards? If it's external rewards, can you substitute in the true external rewards for something that you have internal control over? And even if you can't completely get away this requirement of somebody praising you, getting positive feedback from the outside, at least you can acknowledge the work of it. And if you do get frustrated with the lack of positive rewards from review process or whatnot, you must acknowledge that this is just my part of my being, but it's not a reflection on my quality. It's just something that my what's the gland? It's not pituitary gland. Hippocampus, hypothalamus. Anyway, it's just something that my brain secretes as a response to this text that my eyes see. It's not really doesn't define my place in my family, my society, my peer group. It's simply my body's response to this piece of text, and then externalize that and move on. And finally, I was asked to mention a little bit about industry versus academia as well. I don't have experience in industry. I only worked as a programmer for a couple of years, and that was already nearly 20 years ago. So to me, why I have stuck in academia is that I really do not like having a boss. I like to make my own decisions, set my own priorities, and so on. And the main difference that I see, that also talking to colleagues who have moved on to industry jobs, is the level of control you have. You may have control over work processes in industry as well to the same degree, but you don't have so much control over the content of the science. What's the next question to answer? That comes top down. Entire research programs get shut down and shifted overnight sometimes. And you don't get so much control over the ways of approaching things, maybe. So the friends that I have in industry, they have exciting jobs, they have cool data sets, they have lots of resources, but they can also be forced to say, look, you do now 30 minutes on this project, 30 minutes on this project, 30 minutes on this project. And no, by the way, this thing that you worked on the last 2 years, we're not going to do any drugs based on that kind of data. So basically that entire program is axed, and you can forget everything that you knew about neurodegeneration. So there can be quite quick pivots that are change direction, that are controlled by money, not science. Maybe the science is great, and maybe that questions are on the cusp of being answered, but it's just not budget-wise, doesn't make sense anymore. So that's my take on life in academia versus industry. Okay, so how to be an unproductive researcher. So the unproductive researchers that I've seen across continents and throughout collaboration and so on, most are unhappy, like either with the context that they're in, they don't like their lab, they don't like the supervisor, they have to work with assholes, or just like they think that the work they're doing is not useful, purposeful, and that's really dragging them down, and it's dragging the others down with them. And they're often, if you're not productive, it's by definition they're finishing. Not finishing can be stuck anywhere along the line. It can be picking a wrong, it can be sort of getting stuck in just trying to make everything perfect. It can be thinking about some of the examples. It can be basically not wanting to go through the review process. 17 reviewers comes, I'm just like, it's too much. I'm just going to take off and do this next project. It's having too many side projects, just jumping between projects so that none of them are actually complete. Or it can also be failing to answer a question, and finishing is about filling a gap. You can have a prototype that says, I can do this analysis. In principle, I can take this matrix in and produce this plot. But then you don't actually finish the project by convincing that this now fills the gap. There's something missing, or, okay, yes, so you have this plot now, but really it's all due to this technical artifact. And that's, some of those gaps you just need to address, and not everybody is happy to sort of do the due diligence at some point to support the claim. And I know that there's sort of conflicting information here about doing due diligence, so basically doing lots of work to support the claim, and then not doing all these other things. But there's actually a fairly clean line between the two, where if you make a scientific claim, gender does not matter for genetic control of gene expression of this gene. That's something where you can get a statistical estimate, and you can evaluate it in males and females, and you can look for the difference. And then there are only some set of covariates that you need to consider there to clean up the claim. And others don't matter. Does it? Could it be that there's a genotype interaction? Like it's almost another project. So there's a limit to how much you need to support a claim. Another way that people basically are not very successful or not productive is that they pick suboptimal projects. They don't have enough data to support the claims, or they have a project that basically people don't care about, and it's because they're not answering the question, or there isn't a gap. There isn't demand for this understanding, there isn't demand for this method. And the way to make sure that you have demand is by reading a lot, by knowing the field, by interacting with people. At first, you probably need to trust your advisor because it takes time to read into any field. But then ultimately, you are the best person to understand what the demand out there is, because you will have read the most deeply out of anybody into your field. Even if people are productive, they sometimes fail to sort of grow beyond their PhD. They sort of get stuck in what they did in their first project, and they have one small hammer with which to try to hit everything. And that's sort of a missed opportunity, where others who keep building their portfolio, building their CV, or where opportunities that you can apply to, who collaborate, who go to conference and sort of build a network of connections that they can talk to. They simply have an advantage, and it's reasonable. So it's unreasonable to not take those opportunities. And finally, people who are good get asked to do lots of things. And as you progress in your career and you're productive, you have more and more and more demands on your time. Then the productivity can go down as you respond all to them positively. So you have to be selective about what you say no to. You have to be careful with how you spend your time being alive. And really, as in companies, maybe that's interesting big companies in industry, where in an industry you'd expect that the lowest paid person possible does any of the jobs. Whereas in academia, a lot of the work tends to get elevated upwards, where, I don't want to make this decision, you should make this decision, or something like that. So basically, you should be very, very careful with how you spend your time, how you spend your minutes. Basically, so how not to be in productive research, then, be happy. There's a reason I showed you these pictures. If I couldn't do research anymore, I'd be annoyed. But it's okay. I have other things that ultimately are more important. It's a career, it's a job, but it's also just a job. Yes, I care about understanding, but I could also read a lot about it from books and journals, even if I don't do it myself. Yes, I enjoy it as a way of work, but I don't identify with it to an extent that I should lose sleep over it all the time. And it's okay. Like, this happiness is different for everybody else. If there are people who really like to sort of, in a workaholic way, burn the torch, and that's fine. Everybody has their own way of finding happiness, but ideally you have something that is sort of outside your work that also helps you ground you. And then that's a source of energy and inspiration and just good mood if things at work are not optimal. So not to be unproductive, it's to be productive, it's to finish and to publish. Pick good projects in known fields, read, and be aware of the complexity, the trade-off of complexity of the project and sort of the gain that it can bring to the world. And just sort of also where you are on that slope. You can have grand ideas about unifying everything, but you should move in steps that you can make at any one time. And just keep moving, keep growing, keep developing your skills, keep picking new projects, keep meeting new people, striking new connections. And maybe not play the game, but just be aware of and take opportunities that present themselves. And for that, you also should have an idea of where you want to get to and what you want to do, and then act accordingly. And of course, basically control what you do, control your time, control your agenda, say no to things that don't make sense. And it's okay to say no to people, to push back, even if it feels like you can't. They'll just ask again, or they'll understand that you can't do these things. And on reflection, I thought that most of these things hold equally well in industry and academia. So, but maybe we can discuss this during the sort of live session. Okay, now I'm aware that this is quite a long one. I will take a small break and then say some words about publishing papers as well. So thank you very much. Let's see, I have to stop share and see a large face of myself, and now stop recording. Thank you very much. I look forward to talking to you about these things.